Hi, today I'm going to go through a quick example of using snakemake as a workflow analysis tool in the context here of an engineering finite element analysis, that type of thing. So just to give you a little bit of background before we jump right into the example. So snakemake is a workflow management system, really useful, written in Python, and it goes through steps of defining tasks that make up a workflow, linking those tasks together, and then capturing the dependency so that you can always ensure your workflow, your pipeline is up to date, and you only rerun the necessary bits when particular things change. So snakemake's website's very good. Good place to start. As I say, you define tasks as inputs and outputs, and that creates the dependencies between tasks. In the context of engineering, and in my area of interest is finite element analysis, it's trying to get to that point where you've got a reproducible workflow where you might have a long-running task analysis. You might have hundreds of load cases that you want to consider. So it's trying to organize that and manage that in a sensible way so that you can build on top of it, but you're always ensuring the workflow and the reproducibility. So my example here is available on GitHub, and I'll really just walk you through it. So here's where you'll find it. A bit of a getting started, but we'll just go right through it. So the first thing to do is just to clone that into an area on your hard disk. So if I Okay. Right, we'll just go into that new folder we've created. So there are a number of files in here. For the first place to start, I suppose, is the fact that again, for the reproducibility, the analysis is contained in a Docker environment. So that ensures that we know we've got a stable image there. We know the software versions, and we know it works, and we can share that, knowing that it will work, with colleagues. So going through the example here, the very first thing is to start a container. So to do that, I quite like using kitematic. So I'll just open this up. The command line interface for kitematic. This way just works with my slightly older Mac. Okay, so again we'll just go to the same. Okay, we're already in the right folder. So there's a couple of options. You can use Docker Compose, which I find easiest, so we'll do that. But there's other instructions to use just normal Docker. So we'll run this. That's finished. That's the provision the container. What we'll see now back in kitematic is we'll see we have a new container here, which is the one that we've built. If we can have a look over here, and this is the way I find it's easy to work with is using a Jupyter notebook as an interface, because not only can you look and explore Python code with it, but you can also use that as a shell terminal to interface with things. In this case, like snakemake. So if we go to this, it'll ask us for a token, which we can grab from here. So this is running now within the container. completely separate from your hard drive, and there's a work folder. Within that, now you can see mapped over is the other files that you cloned earlier from the GitHub repository. So this volume on the container is mapped to the volume on your hard drive. And the neat thing about this now is that we can create a terminal and use this to interact with the container. So jumping down the steps now. So the workflow in snakemake in this simple example consists of a snake file which defines the actual tasks and the dependencies, an environment file which defines dependencies in terms of software versions, and that kind of thing, and then there's a config file which in this case is setting up our load cases. So just to show you what those files look like, well, here are our files. Actually, we can look at these on via the Jupyter interface. So if we start with a snake file, so this says input the config YAML file, which is our load cases, and then we have a number of rules, much like a make file if you're familiar with those, starting with a top level rule. What that's doing then is defining the inputs, and we have different steps. In this case, for a finite element analysis, we have input steps where we might be running a number of models. So it might be a base model, a number of load case files, and we'll be outputting files in a different format. And to do that task, there'll be some sort of command. You can run Python commands, shell commands, or R code commands. So in this case, this is just as a dummy example, using a shell command obviously doesn't do much, but you can imagine that calling the an ANSYS run from the command line using the shell interface for that. And similarly, so you've got a task to run the analysis. There's also post-processing steps that can be involved. And you can imagine the benefit of this is as you go along, you've done the analysis once, you might do some post-processing, and then you might build on that. And the way of doing this in terms of tasks means that you're only rebuilding and rerunning tasks that are that need to, because their inputs have changed, their dependencies have changed. So this is a way of keeping everything up to date, but with a minimal amount of rework. So the other one to show then is there's the environment file, which, like I said, is just the defining the dependency. So this is for Conda, the package manager. It's saying the dependencies and in terms of their specific versions, Python and snakemake and so on. And finally, the config file then. So this is the interesting one that you would want to look at. You define a list of load cases. Could be 2, could be 102. So this will run through the workflow and be kept up to date. So in this case, we've got 5 load cases, and in terms of those load cases, we have set up some fictional. We have a model file which is shared amongst all load cases, and then we have an input file for each of our hypothetical load cases, which is kind of typical in a simple way that how you might see it in reality. So back over here. So now we need to back in our container. We need to create our Conda environment using the environment file from our workflow. So let's copy that over and get that going. Okay, after a bit of time, that's now finished installing all of the dependencies defined in that environment file. As it tells you here, to activate that environment, source activate snakemake env, which we'll do. So this puts us in our environment, ready to have a look at the snakemake. So you can see we're in the environment because we're prefixed here with the environment name. So now that we've set up that and we've activated the environment, next thing is to run our workflow that we've defined. So to run our workflow, just like with a make file, it's simply a case of typing snakemake. So in this case, nothing's been done, nothing's been previously run, I should say. So in our directory, we've got our subfolder with models in. We don't have anything else defined, no output files, etc. So if we run this, this is where the good stuff starts. So now it's running our tasks. It's built the model of the dependencies between the tasks, and it's going through it. So there we go. So that's now finished. If we now come back into our workflow, we will see we've now got a whole number of fictional output files and fictional post-processing files from our workflow. If we now try to do the same command again, it's not going to rerun it like a normal script would. It says nothing to be done because our analysis is up to date. Brilliant. So hypothetically, we could we could delete a couple of these, and now there is something to update. So let's have a look. So yes, so it's found some stuff. It's rerun those, and now we're back to where we were. So that's really the basics of it. Just one other thing to show you is that because we've listed our tasks with inputs and outputs, and snakemake has determined the dependencies, we can make a graph of that called a directed acrylic graph, I believe. So that's just going to create that. Okay. So let's see how this looks. So remember, we had 5 load cases that we defined, and we were nominally running those and post-processing those. Okay, so this shows then, so for our load cases here that come out, we run them as a task, we post-process them, and then they come back together at the end of the task. So that shows us the workflow. Obviously, this is a very simple one. It may be that for each case there are lots of different post-processing tasks. It may be that tasks split. They might come back together at the end as part of a reporting workflow. Part of the beauty of doing this as a where your workflow is code, your models are code, and everything is code that can be version controlled. You can do similarly with the reporting. So you could bring all this together, output results to CSV files, have scripts to process it, and then use that to write a report in Markdown at the end of it, so that the entire workflow from model creation, running, post-processing, and reporting is all contained within a pipeline. You can be sure the dependencies are all valid and everything's up to date, and that when something does change, that you need to update the report if a particular file changes. So that's really the sort of basis of it. So I hope you find that useful. The sort of next steps for me really are building on that in terms of taking the example to writing a report from it, including results and including that sort of dependencies. So really that's the kind of next step, and building up on some other software tools like continuous integration, unit testing, and that sort of stuff, which really we should be doing more of in the engineering world as well. Okay, so we'll leave it there. Hope you enjoy this.